So let's practice our Lewis dot structure skills that we learned in the previous video with this molecule, carbon dioxide. First step, determine number of valence electrons. We've got one carbon, which is in group 4. We've got 2 oxygens, each in group 6. Since there's 2 of them, multiply by 2. So I have a total of 16 valence electrons that I need to place in my Lewis dot structure for carbon dioxide. Next step, I need to determine what my central atom is. I use the least electronegative atom, which in this case is carbon. So carbon is my central atom. Scatter my 2 outer atoms around it, my 2 oxygens. Now I begin to start to distribute my 16 valence electrons by first doing single bonds between the central atom and the outer atom. And in this little cartoon that I shamelessly stole, the bonding electrons, the bonds are shown as 2 dots since a bond is 2 electrons. So with those single bonds, I've used 4 of my 16 electrons. I now have to go ahead and complete the octets on my outer atoms. Doing that, I have now used all 16 of my 16 valence electrons. I can't add any more. Both oxygens are happy because they have an octet, but that carbon is not happy. That carbon is not happy because it does not have an octet. So this example illustrates what needs to be done when you have a central atom that does not have an octet of electrons. You look at the outer atoms and see if those outer atoms have any lone pairs of electrons that can be shared to form a double or a triple bond, so the octet of the central atom is satisfied. In this case, we're going to shuttle 2 lone pairs, one from each oxygen, in between the carbon to give us this molecule with 2 double bonds. That is our Lewis dot structure for carbon dioxide. And so you should be able to use those steps to determine Lewis dot structures for molecules. Now, are there exceptions to the octet rule? Yes. Generally, carbon, nitrogen, and oxygen obey the octet rule. Don't have to worry about those. We've already encountered one exception to the octet rule, hydrogen. That's the one you'll encounter most frequently. Occasionally, you will see lithium, beryllium, and boron, due to where they are placed in the periodic table, having less than an octet. Once you get to elements that are after period 3, when you have d orbitals that are accessible to put electrons in, you will often see central atoms that have an expanded octet or more than an octet of electrons around it. That will primarily happen if you have xenon paired with either chlorine, phosphorus, or sulfur. If you follow the rules that we talked about previously for doing Lewis dot structures, particularly the rules in the order in which you place electrons in the Lewis dot structure, you should still get the correct Lewis dot structure. Okay, so I mentioned these exceptions to you. So if you do a Lewis dot structure and something has less than an octet, well, if it's one of these guys or gals, not to panic. Similarly, it's very possible to have expanded octets with xenon paired with one of these nonmetals. There are some other exceptions that you may come across in other classes, particularly if you're a biology major and you talk about free radicals. But in the next video, we'll revisit exceptions to the octet rule and do 2 examples, one with a less than an octet and one with an expanded octet, to do those Lewis dot structures.